So I want to show you guys how to sketch a possible graph for the function if we are given some conditions. So for the first one, we are given that f of 1 is equal to 2, and the limit as x approaching 1 from the negative side is 2, and the limit as x approaching 1 from the right hand side, we get negative 3. So of course, the point of interest is when x is equal to 1. For the other x values, we don't really care, right? So let's just go ahead and start with, let's say here is x equals 1. Now, when we have f of 1 is equal to 2, that means when x is equal to 1, we need to go up to 2, and it must be a closed circle. So we must have this point. Good. Now, for the limit, let's just use open circles. If we have x approaching 1 from the left-hand side, we end up with 2. So go to 1 and 2. Well, if you put an open circle here, there's already a closed circle, so it's closed. And we get 2, so just make sure you graph a function a little bit like this. You can go out like this, you can go out like this, doesn't matter. 1 negative, that means you just go to the left-hand side a little bit. But if you look at this right here, when we have x approaching 1 plus and we end up with negative 3, that means we go down to negative 3. For limit, use open circle, and then it's plus, so just do something to the right, like that. Well, this doesn't look so pretty, so maybe you want to adjust this a little bit, maybe something like this, and then something like that. The only thing that we care is this part, because that will help us satisfy these 3 conditions, and we are done. Based on this, we can also see that there is a jump discontinuity at x equals 1. Now for the next one, we have f of 3 is equal to 1, and the limit as x approaching 3, we get 2. Here we do not have plus or minus, that means you actually have both, right? So have a look. When x is 3, we better have 1. So that says 3 is here and 1 is here. It's the value of the function, so closed circle it is. Now, the limit as x approaching 3, we get 2. So let's say here is 2. For limit, use open circle. Open circle here. It's just a 3, so that means we have both, plus or minus. So you can do something like this, like that. Yeah, that's pretty much it. Of course, you can also go up or down, doesn't matter. You just need to sketch a possible graph. And maybe let's just extend it a little bit, something like this, something like that. All right, what kind of discontinuity that we have here? This right here, it's a removable, so it's just an RD, removable discontinuity at x equal to 3. This is a removable because imagine if you fill in the circle, then you can fix it, it becomes continuous. That's why it's removable. And now for number 3, we have f of 2 is undefined, and if we have x approaching 2 from the negative direction, namely from the left-hand side, we get positive infinity. If we go from the positive direction, namely the right-hand side, we get negative infinity. So here is the deal. F of 2 is undefined. So that means when we have 2, there is nothing, no closed circle at all, right? Now, when we have 2 from the negative side, we get positive infinity. Well, this is not a point anymore, not even an open circle. Positive infinity, that means it goes up, right? So that means, in fact, we have a vertical asymptote. Whenever the output of a limit when x approaching the finite value is infinity or negative infinity, it shows you that we have vertical asymptotes. So when we go from the left-hand side, it goes up, so maybe something like this. Again, this portion doesn't matter. And then when we go from 2 plus, we get negative infinity, and perhaps let me just make it pretty, so let's say it goes down like that. Yeah, and it's meant to be a nice horizontal asymptote. So I only know this part and that part, and the rest I really have no idea. It's just a matter, you just make it look like some functions that you see like a rational function. So just like that. Now, what kind of discontinuity that we have here? It's a vertical asymptote. So vertical asymptote at x equals 2.